So today we're going to talk about our third type of conic section, an ellipse. An ellipse is a set of all points so that the sum of the distances between the line and two distinct points called the foci is a constant. So let's look at what this looks like then. So, clear. For an ellipse, we're going to still be graphing on an xy axis. Then what we're going to have is 2 points that we're going to call the foci. And what happens, and they should be equally spaced from the center, and for today all of our ellipses are going to be centered at the origin. And then what happens is we get something that goes around in such a way that any point that I pick on this thing, if I add up those two distances, it's the same, no matter what point I pick. Okay? So if I add up what those two line segments are, I'm going to get some answer. If I pick any other point, say this point over here, and I add up those two distances, it should be exactly the same as the blue line segments. Okay? So one way to kind of make a perfect ellipse is to take a string and to tape it to a piece of paper or whiteboard or whatever in two spots. Those two spots will be the foci, and then put a pen in it and just draw around. And that will have to be an ellipse because the length of the string is not changing. So whether it's the blue pieces added together or whether it's the orange pieces added together, it's the same no matter where it is. It's the length of the string. Okay? So if you would take a string that has some slack in it and kind of tape it down in two spots, stick a pen in it and draw around, you're going to get an ellipse that way. Okay? So ellipse is kind of like a stretched out circle. So in here we have some important features. So some of the definitions of things that we're going to see in here. We have at our ends the vertices. Okay, so there are two vertices. And then we have at our shorter ends what we call our covertices. Okay, so we have a set of vertices and we have a set of covertices. The vertices are the ones that are further away. Okay, and the covertices are the ones that are closer in. They can't be the same because if they were the same, it would be a circle. Then we have what is called our major axis, and that's the long one. And so then the small one would be the minor axis. An ellipse can face horizontally or vertically, and that is determined by which direction is the longer direction. So this one is longer in the horizontal direction, so we would say this is a horizontal ellipse. Okay? But they could be longer vertically as well, and then we would say that is a vertical ellipse. So here we just kind of went through these different definitions and where we would see those. Then you have a chart. This chart is, again, going to be extremely important to you in working through the assignment, but you don't need to worry about memorizing it. The pieces of information that you will need will be provided for you in a chart on the test. So up at the top, we have two different forms of the equation. There's only one slight difference between them, and that's the location of the letters A and B. Okay? We're told underneath the chart that A is always bigger than B. So the key is, wherever the biggest number is, so remember A is always the biggest number in this problem, wherever that biggest number is under, that tells you about direction. So when the biggest number is under X, it's going to be like the x-axis or sideways, horizontal. If the biggest number A is under the Y, then it's going to be along the y-axis or vertically taller. Okay? But you don't need to memorize this chart. So that gives us then the position of the vertices and the covertices. And underneath this chart is an important equation for us that tells us about the foci. So c squared equals a squared minus b squared, where c is the distance from the center to the focus. Okay, a is the distance from the center to the vertex, the further away one. B is the distance from the center to the covertex. And then c is the distance from the center to the focus. This equation looks a whole lot like the Pythagorean theorem, but it's a minus instead of a plus, so there's a little bit of a difference there. All right, so our first question asks us to draw the ellipse given by this equation. Our first problem is this isn't in standard form. So if we look at the two equations in the chart, they should have fractions in them. And this one doesn't have any fractions. Also, a key feature of the equation of ellipse is that it needs to be equal to 1. And this is not equal to 1. So what can I do to this equation to make it equal to 1 instead of 144? Divide by 144. So I have two options. I can subtract 143, right? But that's not going to give me any fractions. And we know the equation's supposed to have fractions. So if we get this thing to equal 1 by division, that'll give us some fractions in here. We want to reduce. 9 goes into 144 16 times. So 16 goes into 144 9 times. 144 goes into 144 1 time. Now this is in our standard form. So to graph this, what we're going to do is take the number underneath the x, so 16. We are going to take the square root of it, which is 4, and that tells you how far to go in the x direction since it was underneath the x. Okay, so since this number is coming from underneath the x, that tells us about moving for x. So I'm going to go in the x direction from the center 4, left and right. And underneath the y, we're going to take the square root of that number, 3, and since it's under the y, we're going to go in the y direction. Let's get our ellipse then. We're going to connect those 4 points. This question also asks us to find the foci. The equation that will help us with that is c squared equals a squared minus b squared. It's underneath the chart, so you don't need to memorize it. It will be provided for you on the test. C squared is the distance from center to focus, and we don't know where the focus of this thing is, so we don't know c. A squared is the biggest number in the equation. So a squared is 16. You don't need to square it again. It is already squared in the equation. Because when you look at that chart, it tells you that the equation is x squared over a squared plus y squared over b squared equals 1. So they're already squared in the equation. Don't square them again. Okay? A squared is the biggest number in the equation. B squared is the smaller number in the equation. So then c squared is 7, which means c is positive and negative the square root of 7. Graphically, your foci should always be in line with the longest axis. So since this thing is longer horizontally, we are going to go sideways a square root of 7. You can get a decimal to approximate how big a square root of 7 is.
Is this why you toss it plus and minus?
Mm-hmm. Yep, because we're going to go left and right. So the square root of 7 is a little bit smaller than 3, right? I don't have my calculator. Is it 2 point something? 2.6. I'm going to go about 2.6 out to the left and the right, and those make my foci. Now when it says identify the foci in a problem or give the foci, we want to give them as points. So where are the foci? They are right and left, square root of 7, and up none. Some problems, this one doesn't, but some problems in your assignment are also going to ask you to identify your vertices and your co-vertices. So pay attention to your directions. The vertices in this problem are the bigger ones. So they are over left and right 4 and up none. The co-vertices are over 0 and up and down 3. The bigger ones are the vertices, the smaller ones are the co-vertices. From the equation, you can tell where those things should belong because this 16, square root is 4, is with the x. So that 4 should go in the x position of a point. Okay. The 3 came from the 9, which is under the y. So the 3 should be in the y position of a point. So just by looking at the equation, we could actually get these without even the graph. We just want to take the square roots of those numbers and put them into the part of the point that matches the letter they're with. So 16 is with x, so 4 goes in the x spot. 9 is with y, so 3 goes in the y spot. Your foci and your vertices should always match. So if the vertices are in the x spot, the foci should be in the x spot. If the vertices were in the y spot, then the foci should be in the y spot. Your vertices and your foci should always match. Okay, so pay attention to your directions. Some questions on the assignment will just ask you to identify these 3 things. Okay? You don't actually have to graph it to do that. You can grab all of that from the equation just by taking the square roots of the numbers and plopping them into the right part of the point. Okay. Let's do another example. So first, we need to get this thing in standard form, which means set equal to 1 with fractions in it. So what do I need to do? Divide by 100. I'm going to reduce those fractions. So 4 over 100 reduces to 1 over 25, and 25 over 100 reduces to 1 over 4. Then before we graph, let's find our important points. Okay, that's the first group of your homework problem that's going to ask you to do this. So we can do this without graphing. We want to take the square roots of the numbers in the problem. So x, if I take the square root of that 25, I get 5. For y, if I take the square root of that 4, I get 2. So one of my types of points is going to be, since 5 is in the x spot, plus and minus 5 comma 0. Since the 5 was under the x in the equation, I want to put the 5 in the x spot of the point. Another point is going to be 0 plus and minus 2. Since that was in the y part of the equation, it goes into the y part of the point. Now how do I tell from those two which one's the vertices and which one's the co-vertices? The bigger one is the vertices and the smaller one is the co-vertices. Okay, so we don't have to plot it to be able to find that information. To find the foci, we need the equation c squared equals a squared minus b squared. We don't know c squared because that's the focus number and that's what we're going for here. A squared and b squared are the numbers in the equation. So 25 and 4. We don't want to square the numbers in the equation. They already are squared in there. So we just want to take the numbers from the equation. So that means c squared is 21, which means c is positive and negative about 4.6, square root of 21.
So we don't have to draw the...
We are going to draw it as well because this problem asks us to, but the first group of your homework problems doesn't. So I want to show you how you could do this without drawing it. Now, I got this square root of 21, or 4.6, to put into a point, and I know the other part of the point is going to be 0. How do I know which part of the point to put this into? It's got to match the vertices. So since the vertices have a number in the x spot, this needs to have its number in the x spot. So square root of 21 goes there, and 0 goes in the other spot. Your vertices and your foci need to match. So then to put all this information into a picture, for this lesson, we're always going to be centered at the origin. Under the x, when I took a square root, I got a 5. So I want to go 5 to the left and right. Under the y, when I took a square root, I got a 2. So I want to go up and down 2. And that creates our ellipse. And then I'm going to plop the foci in there at about 4.6. The closer those foci are to the center, the more circular this thing is going to be. A circle is actually a special case of an ellipse where the foci are the center. So as those foci get closer and closer to the middle, this thing's going to get more and more round to be a circle. As the foci get closer and closer to the vertices, that's where these things get really pretty oblong. Here, we call them oblique. Okay. Right, our next question asks us to do this kind of backwards. It gives us the characteristics, and we need an equation. So our basic form of an ellipse equation is x squared over something plus y squared over something equals 1. So we have 2 blanks to fill in here. We are told this thing has a vertex at 0, 7. That 7 is in the y part of the point. So it's going to go into the y part of the equation. But when we put it into the equation, what do we need to do with it? Square it. So under the y, we're going to put a 49. The covertex has a number in the x position. So it's going to go in the x part of the equation, but when it goes into the equation, what do I need to do with it? Square it. So it becomes positive 36. That's all there is to coming up with the equation.
You don't do anything with the zeros?
They will always be zeros in this problem since we're centering at the origin. This one has to write an equation again. So we're going to have x squared over something plus y squared over something equals 1. Our vertex has a number in the x part of the point. So we're going to put that into the x part of the equation. But when it goes into the equation, it's going to go in as 16. But then we're given a focus. And the focus doesn't belong in the equation. The focus comes from that c squared equals a squared minus b squared formula. C is the value of the focus point. So c is 2, which means c squared is 4. A squared is the biggest number in the equation, but we only have one number here. So how can we tell whether 16 is actually going to be the bigger one or whether this other one we haven't found yet is going to be the bigger one? The biggest number is not always under x. It could be under either one. This is the vertex, and what do we know about the vertex? It's always the bigger one. Okay? So since the vertex is always the bigger one, then that means the 16 is going to have to be the bigger one. So 16 is a squared. And what we don't know is b squared. If you happen to do them backwards, you're going to end up getting a negative, and we can't have a negative. So you'll be able to figure it out then. So then to solve this out, we're going to subtract 16 from both sides. Gives negative 12 is negative b squared, which means 12 is b squared. And if we look at the standard form of the equation, it looks like this. So what we're missing in our equation is b squared. We actually don't even really care what b is, because in the equation we want everything to be squared anyway. So we want to put the 12 in there. We have two more equation writing examples. So x squared over something plus y squared over something equals 1. The 5 is in the y part of a point. So what do I do with it? Square it and put it under the y. 25 goes under y squared. In the covertex, we have a 4 in the x position. So what do I do with that? Square it and put it under the x. So when you have vertex and covertex, it's not so bad because it gives you one of each. It gives you the x, it gives you the y, and you're ready to go. But when you have the foci, things are a little bit trickier because the focus is not directly in the equation. The vertex is a part of our equation. So the vertex has a negative 6 in the x position. So what do I do with that? Square it and put it under the x. But the focus does not play a direct role in the equation. We need for that the second formula, c squared equals a squared minus b squared. C is the value of the focus. So c squared is 9. The number in the equation will either be a squared or b squared, and we can determine whether it's the a or the b by looking at whether it's the vertex or the covertex. Since this is the vertex is the biggest one and a is the biggest one. So that 36 is going to be the a squared. And so what we don't know is the b squared. Subtract 36 from both sides. And divide by a negative 1. Gives us 27 is b squared. We don't need to take a square root to find out what b is because in our equation, everything is supposed to be squared. It's x squared, it's y squared, it's a squared, and it's b squared. Everything in the equation is a squared thing. So we can just put the 27 in there. Questions? Alright, your assignment is from 10.4 tonight. Notice there are a lot of multiples of 3, so make sure you check those.